Chemical bonding and molecular structure. Let's do some objective questions based on this topic, chemical bonding and molecular structure. Question number 1. Which of the following compounds does not follow octet rule? Look at the options: CO2, PCl3, ICl, ClF3. Let's find out which of these does not follow octet rule. Look at the first option, CO2. The Lewis structure can be written like this. Each oxygen has got 2 lone pairs. So, if you look around carbon, you find 4 bond pairs, that comes to 8 electrons. Look around oxygen, you have 2 bond pairs and 2 lone pairs, that comes to 8 electrons. Again, same is the case for this oxygen. So, this follows octet. Both carbon and oxygen are in octet configuration. Look at PCl3. Phosphorus is the central atom. It is surrounded by 3 bond pairs and 1 lone pair. So, that comes to again octet configuration. Even chlorines have 3 lone pairs and 1 bond pair, that comes to octet configuration. Look at this option, ICl. There is 1 bond pair. On each atom you have 1 bond pair and 3 lone pairs. So, even this is not a violation of octet rule. Now, let us look at ClF3. ClF3 has 3 fluorines surrounding chlorine. Chlorine has used 3 electrons for bonding with 3 fluorines. It will have 4 more electrons in its valence shell, those are present as 2 lone pairs. So, around the central atom chlorine there are 3 bond pairs and 2 lone pairs, that comes to 4 plus 3, 7 electrons. And number of electron pairs are 1, 2, 3, 4, 5. 5 electron pairs comes to 10 electrons around chlorine. So, it is a violation of octet rule. It has 10 electrons around it, more than octet configuration. So, the correct answer is option 4, ClF3. It violates octet rule. It has more than octet configuration. Question number 2. Which one of the following is the highest melting halide? Look at the options. First option is NaCl, second option is NaF, third option is NaBr, and fourth option is NaI. We have to decide which among them has the highest melting point. Remember, melting point of a substance depends on lattice energy. Because all of them are ionic substances, we should compare them on the basis of lattice energy. Whichever has highest lattice energy will have highest melting point. Now, look at the options. Option 1 is NaCl. Option 2 is NaF. Option 3 is NaBr. And option 4 is NaI. In all the cases, the cation part is same. Sodium is the cation, which is common for all this. The species which has smallest anion will have highest lattice energy. So, F minus is smallest among them. So, it will have highest lattice energy. So, the correct answer is 2, that is NaF. NaF has highest lattice energy, therefore, its melting point is highest. Now, question number 3. Question number 3, which one of the following has maximum covalent character? Options are NaF, Na2O, Na3N and NaCl. See, which has maximum covalent character? We need to decide this on the basis of Fajan's rules. Fajan's rule says for more covalent nature, the charge should be high. So, the species which has highest charge is N3 minus. N3 minus, due to its high charge, its polarizability is more, therefore, it is having more covalent nature. So, the correct answer is third option, Na3N. Na3N has N3 minus. I will just write down the cations are common. So, I will just put the anions. Question number 3, F minus, you have O2 minus, N3 minus and Cl minus. Among them, the species which has highest polarizability is N3 minus. This has highest polarizability. It is because of its high charge. Its polarizability is high, therefore, it will get distorted more and its covalent nature will be more. So, the correct answer is third option NH3N. Sodium nitride is the name. Now, question number 4. Which of the following compounds does not have a coordinate covalent bond? Which of the following compounds does not have a coordinate covalent bond? And the options are NH4 plus, PCl5, CH3 taken twice NO and NH3 BF3. And the answer for this question is option 2, that is PCl5. Let us try to find out. Option 1 is NH4 plus. See, NH4 plus has 4 hydrogens surrounding nitrogen, and one of the bonds among the 4 bonds is dative bond. That is why first option is not the answer. PCl5. All the bonds are ordinary covalent bonds formed by sp3 hybrid orbitals. So, this does not have a dative bond. I will put third one also. CH3, CH3, this has to be another CH3 here, tertiary amine oxide, this has a dative bond, and then you have ammonia boron trifluoride adduct. This is ammonia boron trifluoride adduct. So, the bond between N and B is a dative bond. So, all of them have a dative bond, that is coordinate covalent bond, except PCl5. All the 5 bonds are ordinary covalent bonds. These are formed by overlap of, these are sigma sp3d p, sp3d orbital of phosphorus and p orbital of chlorine. And the answer for this question is option 2, that is PCl5. Now, question number 5. Which of the following molecules is polar? And the options are carbon dioxide, BF3, SnCl2 and CCl4. Let us try to find out which of these are polar molecules. Question number 5. Option 1 is CO2. CO2 can be written like this. So, the bond moments of these two get cancelled and the resultant is dipole moment, resultant dipole moment is 0. Option 2 is BF3. It has 3 fluorines in a trigonal planar molecule and the resultant is 0 because the bond moment of these 3 will cancel out each other. Resultant is 0. Number 3 is SnCl2. This is SnCl2. It has got lone pair and 2 bond pairs. So, it is angular. Because it is angular, the resultant will be acting in this direction. Mu r is not equal to 0. But then what about this one? Fourth option. Fourth option is CCl4. This is a symmetric molecule having regular tetrahedral geometry. Because of regular tetrahedral geometry, mu r equals to 0. So, the correct answer is third option, that is stannous chloride. Stannous chloride is polar as it has an angular shape. Had it been linear, it would have been non-polar, but actually it is angular. Due to its angular shape, it is polar molecule. Now, question number 6. The molecule having distorted tetrahedral structure. See, if the central atom has identical surrounding atoms, then it will have a regular tetrahedral structure. CCl4 has a regular tetrahedral structure because all the surrounding atoms are same. Water molecule is not a tetrahedral molecule because it is a triatomic molecule, it is angular. SiH4 is a tetrahedral molecule and all the surrounding atoms are same. So, it is a regular tetrahedral structure. So, the correct answer is CHCl3. It has a distorted tetrahedral structure. The reason you can see is one of the surrounding atoms is H, the other 3 are chlorines. So, because of this difference in these surrounding atoms, it becomes distorted, and this has a distorted tetrahedral structure. So, the correct answer is fourth option. The name of the molecule is chloroform. CHCl3 is called chloroform. It has a distorted tetrahedral structure. Question number 7. Bond angle depends upon, the options are atomic size, hybridization, number of lone pairs, and the fourth option is all the above, and the correct answer is all. All these factors decide bond angle. If the size of the central atom is larger, then the bond angle will be lesser. Hybridization also will decide, like for example, sp hybridization leads to 180 degrees angle, sp2 120, sp3 109 degrees 28 minutes. So, bond angle depends on hybridization. Bond angle depends also on number of lone pairs, like in water you have 2 lone pairs, bond angle is 104.5. In ammonia you have only 1 lone pair, bond angle is 107. So, lone pairs also decide bond angle. So, the correct answer is fourth option, all the above. The next question is question number 8. Which one of the following molecules is nonpolar but contains polar bonds in it? Molecule is nonpolar and contains polar bonds. Look, first option is BCl3. BCl3 as such is nonpolar. Nonpolar, that means mu equals to 0, but the bond moment is finite. So, this is the correct answer. Look at the second option, H2, mu equals to 0, and polar bond is also not there. Only one bond is there, and that is between identical atoms. Look at ammonia. The molecule as such is polar. So, it is not a non-polar molecule, it is a polar molecule. On CHCl3 also has mu not equal to 0. So, the correct answer is boron trichloride, whose dipole moment, resultant dipole moment is 0, but the bond moment is finite. So, the correct answer is option 1, that is BCl3. The molecule as such is non-polar, but the bonds are polar. Question number 9. Which one of the following does not exhibit paramagnetism? Which of this does not exhibit paramagnetism? Look at the options: O2, O2 plus, O2 minus, and O2 2 minus. See, in O2 you have 2 unpaired electrons in the pi star orbitals, which are degenerate orbitals, but in O2 plus there is only one unpaired electron, because this O2 plus is formed from O2 due to loss of electron, and O2 minus is formed due to gain of electron. O2 minus has one unpaired electron. O2 2 minus, here O2 2 minus is formed from O2 by accepting 2 electrons. Both the unpaired electrons will get paired up. Question number 9. O2 has pi star px1, pi star py1. This is the configuration of O2. O2 becomes O2 plus by loss of electron. The configuration now is pi star px1. It still has one unpaired electron, so you expect it to be paramagnetic. O2 minus, this happens due to gain of electron, it becomes O2 minus, it becomes pi star px2, pi star px1. This is responsible for paramagnetic nature. Then you have gain of 2 electrons, it becomes O2 2 minus, configuration becomes pi star px2, pi star, both the electrons will get paired up. So, this is diamagnetic, this is paramagnetic, this is also paramagnetic, any species which has unpaired electron, at least one unpaired electron will be paramagnetic. So, the correct answer is O22 minus. O22 minus is the only species which is diamagnetic. Question number 10. In which one of the following pairs the two species are isostructural? The two species are isostructural. Isostructural literally means having same structure. Question number 10. BrO3 minus XeO3. It has got a lone pair and 3 surrounding oxygens like this. So, what is the structure? It is pyramidal. Same is the case with xenon tetroxide. It has got a lone pair and 3 surrounding oxygens. This is also pyramidal. So, the correct answer is first option. But let us look at the other options also. This is option 1. Option 2, it has SF4 and XeF4. SF4 has one lone pair, XeF4 has 2 lone pairs. So, this is seesaw shape, this is square planar. Number 3, third option, SO3 2 minus and NO3 minus. SO3 minus has pyramidal shape because it has got a lone pair, whereas NO3 minus has trigonal planar. It has no lone pair on nitrogen. And about the fourth option, BF3 and NF3, BF3 is trigonal planar and NF3 is pyramidal. So, they are not isostructural. What makes NF3 pyramidal is presence of lone pair on nitrogen. You do not have lone pair on boron. So, the correct answer is option 1, that is bromate and xenon trioxide both have same structure, they are isostructural, both are pyramidal. Question number 11. The NN bond distance is maximum in. The question is regarding longest NN bond. So, obviously, fourth option is ruled out because it has got only one nitrogen. So, there is no question of presence of NN bond. Let us decide between N2O3, N2O and N2O4. This is N2O3 and then this is N2O. N2O has NN triple bond, so it is shorter obviously than this. So, this is ruled out. Let us look at N2O4. This is N2O4. Here oxidation state of this nitrogen is +3, this is +2, both are +4. As the oxidation state increases, size decreases, and as the size decreases, bond length becomes shorter. So, this will be shorter than this because of higher oxidation state, its size is smaller. Due to smaller size, the bond length will be shorter. So, the correct answer is option 1, that is N2O3. N2O3 has the longest NN bond. Question number 12. Which one of the following substances has the highest lattice enthalpy? Options are NaCl, Cl2, MgO and BaO. Lattice enthalpy depends on charge density. Charge density, MgO has highest charge density for both cation and anion. So, MgO is expected to have highest lattice energy. MgO consists of Mg2 plus and O2 minus. There can be a great strength force of attraction between Mg2 plus and O2 minus, therefore, its lattice energy is expected to be highest. Whereas, in all other cases either the cation is large as in case of barium oxide, or anion is large as in case of NaCl and CaCl2. So, MgO has highest lattice energy due to high charge density of both cation and anion. Question number 13. In which one of the following pairs of molecules the two species have identical shape but differ in hybridization? Shape is identical but hybridization is different. Look at the options. Option 1 is a pair of ammonia and BF3. This is ruled out because they have different shape. Ammonia is pyramidal, ammonia is a pyramidal molecule, whereas BF3 is triangular. So, this is ruled out. Second option is I3 minus and BeCl2. Both are linear. I3 minus and BeCl2 both are linear. But then we need to check hybridization. In I3 minus, hybridization is sp3d, whereas in BeCl2 it is sp hybridization. So, they have same structure but differ in hybridization. So, the correct answer must be second option. But let us look at third and fourth option also. HCF2 and I3 minus. Both are linear. I3 minus has sp3d hybridization, even HCF2 has sp3d hybridization. So, this is not the answer. Number 4, NH4 plus SF4. NH4 plus and SF4 plus differ in their geometries. This is tetrahedral, SF4 is seesaw shape. This has got one lone pair. This is sp3, this is sp3d hybridization, no doubt, but they differ in their geometries also. Question number 14. Which one of the following has a dipole moment? Look at the options. The question is regarding polarity, which is having dipole moment. That means which is a polar molecule, and we need to decide between which is polar and which is non-polar. The options are CS2, CCl2F2, SO3 and SnCl4. Question number 14. CS2 has zero dipole moment. It is because of linear shape. Mu is not equal to 0. This is a polar molecule because all the bonds are not identical. Number 3 is SO3. SO3 is a triangular molecule, so mu equals to 0. Then the last one, SnCl4, it is tetrahedral, no lone pairs are present, so mu equals to 0. So, the only polar molecule among them is CCl2F2. This is a polar molecule, dipole moment is finite, non-zero. Now, question number 15. Which one of the following has the same hybridization in sulfur as that of hybridization of xenon in xenon tetrafluoride? First of all, let us try to find out what do you have in xenon tetrafluoride. Xenon is surrounded by 4 bond pairs, so obviously there are 4 non-bonded electrons as 2 lone pairs. So, this is 2 lone pairs and 4 bond pairs. So, the hybridization must be sp3d2. Now, we need to fish out the compound of sulfur where sulfur is in sp3d2 hybridization. So, among the options, SF6 has sp3d2 hybridization. So, the correct answer is SF6, third option. In H2S, pure orbitals of sulfur are involved in hybridization. H2S, pure orbitals are involved in bonding. So, H2S is not the answer. In SF4, the hybridization is sp3d because it has got one lone pair and four bond pairs, and S8 is ruled out obviously because each sulfur is bonded to two other sulfur atoms. So, there need not be any hybridization. If at all it is there, it can be taken as sp3 hybridization. So, the correct answer is third option, SF6. SF6 and XCF4 both have sp3d2 hybridization. Question number 16. Which one of the following atomic orbitals are always involved in sigma bonding only? See, among these, s orbital has a spherical shape. So, because of its spherical shape, it always forms sigma bond. It cannot undergo lateral overlap. So, it cannot form pi bond, it can form only sigma bond. So, the correct answer is first option, s orbital. The reason is its spherical shape. Due to its spherical shape, it can always form sigma bond, it cannot form pi bond. Question number 17. Which one of the following molecules is planar? Options are CH4, BF3, PF3, NH3. CH4 is tetrahedral, so it is non-planar. BF3 is triangular. So, the correct answer is BF3, trigonal planar or triangular molecule. PF3 is pyramidal, and the fourth option NH3 is also pyramidal. So, the correct answer must be BF3. BF3 is trigonal planar. Question number 18. A diatomic molecule has a dipole moment 1.2 dBi. If the bond distance is 1 angstrom, what percentage of electronic charge exists on each atom? What is the percentage of charge on each atom? 12%, 19%, 25% or 29%. Question number 18. Mu observed is 1.2 dBi. Bond length given in the question is 1 angstrom. So, we need to first find out mu theoretical. This is mu theoretical equals to 4.8 into bond length, that comes to 4.8 dBi. Percentage charge is given by mu observed by mu theoretical into 100. So, that comes to 1.2 by 4.8 into 100, which comes to 25%. So, the correct answer is option 3, 25%. Question number 19. Which one of the following cannot exist on the basis of molecular orbital theory? Options are C2, He2 plus, H2 plus, He2. According to molecular orbital theory, any species whose bond order comes out to be 0 will be non-existent. It is 0, bond order is 0 for He2, therefore, He2 does not exist. Answer is fourth option, He2. The reason for its non-existence is, I will tell you once again, is its 0 bond order. Question number 20. Which one of the following has more tendency to form covalent compounds? Here we need to apply Fajan's rules. A species having small cation will be predominantly covalent. So, among barium, beryllium, magnesium and calcium as given in the options, first option is barium, second option is beryllium, third option is magnesium and fourth option is calcium. The smallest among them is beryllium. So, beryllium will have more tendency to form covalent compounds. Majority of compounds of beryllium are covalent. The reason is its small size, very small size of Be2 plus. So, according to Fajan's rules, as the cation size decreases, covalent nature increases and ionic nature decreases.